In this demonstration, we're going to take a look at pure virtual functions and pure virtual classes in C++. A pure virtual function is like an abstract function in other languages like Java and C#, and a pure virtual class is like an interface in those languages. So let me show you what files we've got. I'll show the header files first. We'll start with bank account. So this is quite a simple class. It defines a simple bank account with a balance, constructors and destructors, a method to get balance. I haven't declared the get balance method as virtual because I don't want it to be overridden in subclasses. The deposit and withdraw methods are overridable because potentially subclasses might have different rules for whether a deposit or a withdrawal is allowed under different circumstances. So those can be overridden by subclasses, but they don't have to be. In contrast, the next two functions are pure virtual. The equals 0 at the end makes these pure virtual functions. That means that these functions aren't implemented at all in the base class. Effectively, they're abstract methods, so they must be overridden in subclasses. Okay, so that's my bank account class. By virtue of the fact that it has one or more pure virtual functions, then effectively we can say that this is an abstract class. There isn't actually an abstract keyword in C++, but you can imagine it being there just here. Okay, so that's our bank account class. The next thing I'm going to show you is a couple of effectively interfaces. Freezable is a class. It contains two pure virtual functions. The idea here is that you can freeze an object or unfreeze it. So we're going to show how you can freeze savings accounts so that you can't deposit or withdraw, and you can unfreeze them so you can then deposit and withdraw. But the basic idea is that we define it as a class. It contains only pure virtual functions, so we call it a pure virtual class. Or if you were a C# or Java developer, you would call this an interface. Likewise, loggable. Loggable is a pure virtual class. It has just pure virtual functions and nothing else. The loggable interface, as I'm going to call it from now on, has the ability to log a message on the screen. It's pure virtual, remember, because of the equals 0 syntax at the end. So we have the bank account class, which is effectively abstract. We have the freezable class and the loggable classes, which are effectively interfaces. And now we're going to see how to implement all that in savings account. So let me tell you about this. This shows how to implement multiple inheritance properly in C++. That's why C++ has multiple inheritance. You typically implement one proper base class, if you like bank account, plus any number of additional interfaces, if you like, such as freezable and loggable. So just from a purely syntax point of view, savings account inherits from the bank account class publicly, and the freezable class publicly, and the loggable class publicly. You have to say the public keyword each time. If you missed out the public keyword here or the public keyword here, then it would default to private. So you have to say public, public, public for every base class if you want it, of course. So a savings account inherits mainly from bank account, and as well as the balance from the bank account class, it also has an interest rate. Savings accounts earn interest. Plus there's a flag here indicating whether the current savings account is frozen or not. So we have a constructor and a destructor. We have an additional method, savings accounts earn interest at the specified interest rate, presumably. We've chosen to override the deposit and withdraw methods. Those were virtual methods in the bank account class. We didn't have to override them, but we have. We have to override these two methods. Those were the pure virtual functions from bank account, so we have to override those in our class. And in the same kind of way, because we inherit from freezable, freezable had a couple of pure virtual functions also, so we have to implement them. And the loggable class has a log method that we have to override as well. So we've completed the implementation of savings account. Let me show you what the implementation looks like. So the implementation for bank account, that's quite straightforward. A constructor and a destructor, a get balance method, deposit and withdraw. Nothing particularly interesting there. Freezable and loggable, of course, they don't have any implementation because they just had pure virtual functions. So that makes sense. Now let's have a look at savings account. So there's quite a lot of detail here. I think the main thing to point out is that we have overridden methods that we had to from pure virtual methods in the superclasses. So savings account calls the base class constructor, initializes the additional interest rate in savings account, plus the frozen field. We say that savings accounts aren't frozen initially. That would make sense. The destructor doesn't do anything, it's just there. The earn interest method, and similarly with deposit and withdraw methods, the first thing they do is to check the frozen flag. If the account is frozen, then nothing happens. If the earn interest method is called, only if the account isn't frozen will it go ahead, calculate how much interest is earned at the specified interest rate. So for example, if the interest rate was 5 divided by 100 gives us 5%, and then we multiply that by the balance to work out how much interest is due, and then effectively we just deposit that amount into the account. That's the amount of extra money that will be added to our bank balance, which is quite nice. Likewise, the deposit method, it checks that first of all that we're not frozen, and if we're not frozen, it just calls the base class version of deposit to actually do the work, add in money to our balance, and it just outputs a log message. That's the log message that we've implemented from the interface, the loggable interface. I'll show you that log method in a moment. Let me just scroll down a little bit further to bring the rest of the class into view. Okay, so the withdraw method is similar to deposit. Check that the account isn't frozen. Oh, also make sure we have enough money, because savings accounts aren't allowed to go overdrawn. If we have enough money, then invoke the base class method to actually withdraw the money out of the account and log that event on the console. These two methods get the terms and conditions for this particular type of account. It's like a description really for what this account offers. And the guaranteed limit, many countries around the world offer a guaranteed limit when you invest in a bank. So if the bank went bankrupt, out of business, the government will step in and give you up to £75,000. So if you have 76,000 and the bank goes bankrupt, the government will give you back 75,000 and then you lose the other 1,000. That's the idea behind that method. And then finally, we implement the methods from the freeze interface. You can unfreeze or freeze your bank account, and then we implement the method from the loggable interface just to log a message on the console. So savings account implements its own behavior plus implemented methods that it chose to, like deposit and withdraw, plus implemented methods that it had to by virtue of the pure virtual functions in the base classes. So that would be these methods here that we have to implement from bank account, these methods here that we have to implement from freezable, and this method here that we have to implement from loggable. So that's pretty much the demo. I just want to actually show you what the main code looks like, and then we'll run it just to see how it works. Okay, so first of all, let's just skip over that function. In a moment, I'll come back to it. We create a savings account, and I deposit and withdraw some money, and I earn some interest. That's very nice. So those methods will work, if you like. Then I call the freeze_me method. The freeze_me method up here, notice that it takes a freezable interface. This is one of the reasons for using interfaces or pure virtual classes. This function doesn't really care what kind of object you've passed in. All it cares about is that you pass in some kind of object that happens to implement freezable. And then it calls the freeze method. So now the bank account is frozen. So these deposits and withdrawals and interest don't take effect. So what we do is we then unfreeze the bank account, and then we make some more activities, and these methods should actually have effect. Okay, so I'll just scroll this out here, and I'll run the application and we'll see what happens. Okay, so it displayed the terms and conditions. That's these methods up here, the terms and conditions and the guaranteed limit. Those are the methods that we had to implement from bank account, and we have. And then these are the deposits and withdrawals, and that there's the earned interest method, the deposit there. those are the first 4 calls here. These calls, 1000, 2000, they aren't listed because the account is currently frozen. However, after we've unfrozen the bank account, then when we make some bigger deposits and withdrawals, those methods are. Okay, so that's the end of the example. What we've seen here is how you can define pure virtual functions in a class and how you can then implement them in a subclass.